Hi everyone, I am Sahit Vilmula. Here I am going to explain about deep learning model development and performing the evaluation using ANN and wide and deep architecture. And here we aim to protect the case facility ratio using the architecture, machine learning pipelines comparing the basic ANN against and the more complex of width and deep architecture to see more accurate and the complexity of translated to the better performance. And here we can see we imported the enrollment steps by library imported uh, num panda matlab and sklearn, transflow kls, everything are we imported from the machine learning pipelines. And here the video uploaded the data, uh, to the rows of 4, 11 and 14 columns, dropping the categories and strings to return the only numerical features and removing the missing values. And here the we cleaning, data cleaning, like we use the fpfs and administration province state country region, the last update and combine keys to get the data cleaning. And here that feature transformation, like the confirm the dates and record and actives and everything. And here the data description, the like how many dates are done and how many record and how many active and in rated and case facility ratio. We can see here the count number 39.4 is the highest ratio. And here the correlation heat map. We can see the here while looking the map, dark, which one is the dark, like one is a positive and here the blue is minus 0.18 is an negative. You can see the overall the heat map. And here the feature selected to get the facilities ratio. uh, y is equal to df of k facility ratio and x is equal to drop of case facility ratio as axis of one. Here the testing the data, x test and x train and x test and y train and y test. Like training is 80%, testing is 20%. And here the future scaling, like extend file transformation and xtest is scale transformation xtest. And here the hyperparameter tuning e plus ann, like architecture of tuning, like hidden layer sizes and dropouts, like testing the 150 approaches and loss by metric to get the optimization, the tracking, the subredding, like that sizes of data. Here we can see the data. And here the hypermetrics of tuning the with the wide place and deep like architecting the spot into the like two parallel paths, like width path is like single density layers, like 64 to 256 units, and it capture the linear relation and the future interaction. And deep deep is like deep is for the multiple layers, back norms and dropouts and the outliers of single regression. And here the tuning, like tuning the five trailers which is due. And here like monitoring the values of loss by patients of 10 and restoring the weight and extend and weighting approaches of batches and batch size is number and splitting everything. And here we can see the data. And here the comparison the using the bar chart, like modeling and RMSS, AME, R square, like converting the data for the plot, I bar ID over various like model, various name is metric and values name of value. And here the bar chart is figure like 8 by 8 comma 6 and the x matrix and y value and huge is symbol. And here we can see the model performance of comparison of models like RMS, AME, R square of wide, ANN and wide of models. We can see the scores, like RMS is the 0.61, ANN and 0.492 and AME of 0.287. And like wide and range of depth is 0.2, R square is equal to 0.781. Wide and range of R square is equal to 0.81. uh, Thank you.